Hi guys, welcome back. Today is November 10th. So happy Tuesday. We are continuing where we left off. So yesterday we talked about ions. And today we're going to talk about isotopes. Last week we spoke about atoms. So we're going to do a brief recap of those topics that we discussed last week and Monday, and then we're going to get continued with today. So our learning target has just changed from I can now differentiate isotopes from atoms, right? Go ahead and do now. It's also a brief recap to see if you truly got what we talked about yesterday. And let's go ahead and get started. So, first information I'm going to bring up is about atoms. We covered atoms last week, and we said that atoms are the smallest units of matter that contain a neutral charge due to the protons being equal to the electrons, right? And a couple of information about atoms that we need to know, and we need to make sure that we know this like the back of our hands. So protons are positive and they're found in the nucleus. To determine how many protons we have, we're going to look at the atomic number, which is a bold number underneath our symbol on our periodic table in our chemistry reference table. Our neutrons are going to be neutral. They're found also in the nucleus. To calculate the neutrons, we're going to take the mass number, which is on the top left side of our element tile on our periodic table, and we're going to minus it from the atomic number. And next we have the electrons. Electrons are negative. They're found on orbitals that are around the nucleus. And to find out how many electrons we have, it's going to be protons. It's going to be equal to the number of protons we have. So if we have 5 protons, we also have 5 electrons. If we have 7 protons, that means we have 7 electrons. If we have 8 electrons, that means we have 8 protons, right? So at this moment, our atom is neutral. However, Monday we learned that our atom doesn't always stay neutral, and this introduces ions. Ions are atoms that have a charge due to the protons not equaling the electrons. We have 2 types of ions. We have cations, which is a positive ion because electrons are lost. Usually the name ends in an ion, so we have calcium ion, magnesium ion, sodium ion, right? And obviously if we see Na+2, we know that that's sodium. It's going to lose 2 electrons. So instead of it having 11 electrons, like the number of protons it has, it's actually going to have 9 electrons, because that +2 means that we're going to lose 2, right? And then we have anion, which is a negative ion. Electrons are gained. Usually the name ends in an I. So that's chloride, bromide, fluoride, oxide, right? And those are when we gain electrons. So if you see O-2, that -2 means that you've gained 2 electrons. So instead of oxygen having 8 electrons like we know it's going to have, because our electrons equals our protons, it's now actually going to gain 2 electrons and have now 10 electrons, right? So if this confuses you a little bit, see yesterday's video. That would really explain it. However, I realized that the thing that I did forget to explain to you guys yesterday is why ions form. And this is known as the Octet Rule. And I think I explained it towards a little bit at the end of last week's video. But I want to explain it again. The Octet Rule says that for our atoms to be stable, they must have 8 electrons. In the case of helium and hydrogen, they must have 2 valence electrons, but in every other element's case, they must have 8 valence electrons. Now, if we look on the periodic table, we're going to notice that there's only one group of elements that have 8 valence electrons, and those are the noble gases. They're noble, they're fine, they can be seen in nature as is. However, the other elements that we have on the periodic table cannot be seen in nature as is. So they need to bond. Right? They need to go through a chemical reaction to be able to be stable and to be found in nature in that form. So with that being said, our atoms go through gain and lose electrons, right? Through chemical reaction. Now, some of them, if we look, for example, at sodium, right? Sodium has 1 valence electron. So it's either going to lose that 1 valence electron, so it can have 8 electrons in its last shell, or it's going to gain 7 electrons to have 8 electrons in its last shell. it's for sodium, it's going to be easier to lose that 1 electron than gain 7. However, if we look at fluorine, fluorine has 7 valence electrons in its last shell, right? It's either going to lose all 7 or gain 1 more. In the case of fluorine, fluorine is going to gain that 1 more because it's easier to gain 1 to get to 8 than lose 7 to get to 8. All right. Hopefully that makes a little bit of sense. If you are struggling with that, please let us know, and I'll most definitely create another video on that concept, or you can come see us in tutoring after school. And so we are going to be talking about isotopes. So isotopes, it's an atom that contains, sorry, I don't know why it says a never mass. It's an atom that contains, so sorry, I had to fix that real quick. So isotopes is an atom that contains a new mass that isn't written on the periodic table. In essence, it has the same atomic number and protons, but a different mass, thus a different amount of neutrons. So now we're not focusing on electrons changing, we're focusing on the neutrons changing. And we're going to be able to differentiate which one, how many neutrons are in one type of isotope than another type of isotopes, right? So we're going to look at that now, but before we can even look at that, we also need to look at the notation. We have to look at a notation. So if we want to simplify, before we move on, if we want to simplify the term for isotope, it has the same number of protons, different number of neutrons. It has the same atomic number, but different mass, right? So let's go ahead and talk about notation. So there's 2 types of notation that we get with isotopes. There's isotopic name and isotopic notation. You're going to see more of names today than you are going to see of notation. However, do not get confused with notation. It's very important. So isotopic name, which is right here, which is chlorine 35. So we have the name of the element and the atomic mass, or the mass number it now has, right? While isotopic notation has the symbol, the mass number on the top left, and then it has the atomic number on the bottom left. So isotopic notation just tells us, isotopic name just tells us the element's name and the atomic number. Once you're given the atomic number, not the atomic number, the atomic mass. Once you're given the atomic mass, you have to use that mass. So if it's chlorine 35, the mass is 35, not what you see on the periodic table. If you're given chlorine 24, you're using the mass number 24, not what you see on the periodic table, right? It's very important that you follow what is given to you in the name, not what you see on the periodic table. Now the periodic table's mass no longer counts, right? So let's go and do a couple of practice so we can see how this works out. So we have carbon. Let me get a pen and write out. So we have carbon. The symbol for carbon is C. The atomic number is, it's not 4, it's 6. Sorry about that. Right? The atomic mass is 12. So the isotopic name for carbon is going to be carbon / 12. And my isotopic notation is going to be C. Up here is going to be my mass, so it's 12. Down here is going to be my atomic number, which is 6. All right. Let's go ahead and let's do boron. All right. So boron, the symbol is B. The atomic number is 4. No, I lied. The atomic number is 5, right? The mass number, so boron has a mass of 10.81, but we're going to go round that off to 11. So let's go ahead and let's write that in our isotopic name. First thing, we're going to write the name. So it's boron. And then our mass, which was 11. Right? And then our isotopic notation, we're going to have B. On the top right here, we're going to have the mass, which is 11. And then on the bottom right here, we're going to have the atomic number. All right. let's do nitrogen just so you can get that out of the way. So the symbol for nitrogen is going to be N. The atomic number is going to be 7. The mass 14. So we're going to write that. We're going to write nitrogen. Sorry, I think the thing is just glitching a little bit. Nitrogen. And then the mass is 14. And then let's go ahead and write our isotopic notation, which is going to be N here. And then up here, we're going to have our mass, which is 14. And then we're going to have our atomic number, which is 7 over here. All right. Also, don't get so used to the fact that sometimes you might not see the atomic number present. You might just see the mass and the symbol. That's perfectly fine. Just know that the atomic number never changes for that element. It makes the element what it is. So our number of protons will never change. As we've learned recently, our number of electrons can change and our number of neutrons can change. But one thing that always remains constant is our number of protons will never change. Thus, our atomic number will never change. Alright, so let's go ahead and let's practice a little bit more with these isotopic names. And let's get used to determining how much neutrons we have in these isotopes. So we had this example. I'm going to do this example with you, but in your notes you have a little bit of more of them, right? So we're working with nitrogen 15. Remember, this is the mass, and nitrogen 20, and this is the mass, right? So the 15 and 20 are the mass. We're going to find the protons, neutrons, and electrons for them. So remember, the number of protons does not change. That's not changing, right? So if we're working with nitrogen, our number of protons is going to remain the same. It's going to be 7 and 7. Now, because we're working with isotopes and not ions, our number of electrons do not change as well. So if we have 7 protons, we would then end up having 7 electrons. But because we're working with isotopes, our number of neutrons changes. So to find the number of neutrons, we're going to take the mass and subtract it by the atomic number. Right? So in nitrogen 15's case, we're going to take 15 minus 7. I'm not going to take 14 because 14 is the mass on the periodic table. We're going to use the mass that's written next to our element. So 15 minus 7 is going to be 8. So in this case, nitrogen 15 has 8 neutrons. Let's do nitrogen 20. It's going to be 20, because that's my mass number, minus 7, which is our number of protons. I don't know why this is glitching. So we have 20 minus 7, and we're going to get 20 minus 7, we're going to get is 13. Right? So in nitrogen 20, we have 13 neutrons, but in nitrogen 15, we have 8 neutrons. Alright, so go ahead, finish the practice with this, and if you have any questions, please feel free to reach out to me and Mr. Schwartz. We most definitely will be here to help you. If you feel like you need more practice, you can attend after school tutoring on Zoom, which starts at 2:25. Have a great day, guys, and see you around.